Okay, so we're taking a look at 51. Remember, what's inside the trig affects the x's, what's outside the trig affects the y's. I just realized I didn't finish writing this. Let me just finish the table. Okay, so this has a vertical compression because 2/3 is like 0.6666666, and rounds up to 7. Sorry, like 0.67. I don't know if I said that clear. So it's 2/3 is less than 1, so it's a vertical compression. The b value is 1/2 and the c value is -pi/4. These two together, this sort of blends when you have a b and a c. All right, so let's start, you know what, let's just start with the range. So the range is 2/3 of what it used to be. So all the values, you multiply them by 2/3. So I'm multiplying all these values by 2/3. I'm shrinking them. All right, now I'm going to do all the calculations for the x. So again, the period is 2 pi divided by b. b in this case is 1/2. So it's 2 pi divided by 1/2. Make sure that you recognize that you have to flip that up. Right, that actually is going to become 2 pi times 2/1 or 4 pi. This is a stretch. It's a horizontal stretch. So that's the period. Then the increment is always the period over 4. So it's 4 pi over 4, which is pi. That's your increment. So the increment is the distance between the dots, right? It's the horizontal jump you're going to make to get to the next point. It's how far you have to jump. All right, we got to do the interval, which is the start and the stop. So this was the old stop. We're going to calculate the new stop. So to do that, you take the insides of the trig function. I call it the guts. You take the guts and you set them equal to the old stop and you re-index them by solving them for x. So I'm going to move the pi/4 to the other side. I'm going to multiply both sides by 2 to get rid of the 2 under the x. I'm going to reduce over here, so this is pi/2. So the new start is pi/2. You don't necessarily need to calculate the stop because you can figure that out from the increment by adding pi, but I'm just going to work that out for you because some people like to see it anyway. All right, so the new stop. This was the old stop of 1 cycle. All right, so you set it equal to what it would have been, which is 2 pi, and then you solve it. All right, so I'm going to move the pi/4 to the other side by adding it. Now you're going to have to get an LCD, right? So you're going to change 2 pi to 8 pi/4, right? You got to get the LCD. So 8 pi/4 plus 1 pi/4 is 9 pi/4. So 2 pi plus pi/4 is 9 pi/4. I have it sort of squeezed in there, so make sure you understand what I did. I got an LCD. Got to get rid of the 2 from under the x. So I'm getting 9 pi/2 as my new stop. That means it's going to finish at 9 pi/2. All right, now we got to fill in the middle ones. So how you fill in the middle ones is you add the increment to it. And this should make sense to you. Like this is 1/2 a pi. It goes to 9/2, which is 4.5. And that makes sense to me because 1/2 a pi plus 4 is 4.5. So that lines up. All right, so now I'm gonna do this. So I'm gonna add pi. So make sure you're getting an LCD. Like I'm sort of just doing this in my head. Right, if you have 1/2 plus 1, that's 3.5. But you can do the LCD. 3.5 plus 1 whole is 5/2. 5/2 plus 1 whole is 7/2. 7 over 2 plus 1 whole pi is 9 pi over 2. So again, you could do this work on this side, but I'm just sort of crunching it out. All right, let's draw. Okay, let me just sharpen this guy. All right. So now you just sort of take a moment because you want to make sure that your graph is scaled correctly. So how you just sort of take a moment and you get them on some kind of middle ground where you sort of can compare them. Like this is less than 1. This, I'm going to round this to like 3 over 2 because pi is like 3. This is like 3 over 2, which is 1.5. So yeah, this side is twice as large. Well, not twice as large, but it's quite a bit bigger than this side, right? It's quite a bit bigger. It's actually more. It's more than twice. Okay, so I'm gonna start with. All right, I'll start with the pi over 2 jumping by pi. Now be careful how you do this because it's starting at pi over 2, but it's jumping by pi. So that means that let me maybe say it this way. It might be easier to catch. The distance between the jumps doesn't include 0. It's actually going to go from negative pi over 2 to pi over 2 to 3 pi over 2. So this is not the correct magnitude right here. It's actually twice this. That's why this guy's a lot longer, because I have to jump a distance of pi. If you make this really close, you've only jumped a distance of half of pi, which we're not doing. We're jumping a whole, right? The distance from here should be pi. The distance from here to here is only half a pi. So this should look twice as big as this space. All right, now I'm going to jump another pi. Now we're at 5 pi over 2. Then I'm going to jump another pi. 7 pi over 2. Then I'm going to jump another pi. 9 pi over 2. I got the pi over 2, 3, the 5, the 7, and then okay. You guys know we're going to have to do more, so I'll do a little bit on each side. I'll go a little bit more this way. 11 pi over 2, 13 pi over 2. I'll go a little more this way, a little more this way. So I've got to jump a distance of pi. This is only half of it, so I got to jump farther. If I add pi, that's negative 3 pi over 2. If I add pi, it's negative 5 pi over 2. Okay, that's enough of the jumping. So this magnitude is equal to one of these other ones, is what I'm trying to say. This whole thing, this half and half is one whole. All right, now this is the part what I was trying to say earlier. Let me just erase this. So this is 3 over 2, which is 1.5, and you want to draw 0.66666, which is less than half of that. So if this is, just do your best. I'm not looking for perfection. This is about 0.75, so underneath that would be about, okay, that would be about, so what I did was I made this magnitude equal. So if this is about 1.5, then this is about 0.75, then this is about 0.66666. It's around there. Okay. I'm not taking a ruler to your exam, I promise. All right, 2/3, and no, I have to push that down way farther. 2/3 is this guy. Is this guy here? And then I need this guy. So this guy's really squeezed in here. I'm using this line here, okay? All right, so now we're gonna, as you guys have seen me do before, we're gonna plot the point. So pi over 2 and 2/3. I'll just call it out. It's a little hard for me to swing back and forth. 3 pi over 2 and 0. Then we go down to negative 2/3. Then we go back up to 0. Then we go up to 2/3. All right, that's one cycle right there. So let me just get the concavity correct on it. This part is concave up. This part is concave down. This part is concave down. Okay, that's one swing. That's one swing through it. Now let's add some more, okay, because they asked for 2 periods. So let's just add some more. So just follow the pattern. You know, the pattern is down, middle, up, right? So if you're up, you got to go back to the middle and then down. All right, so let me finish this guy. This is concave down here. This is concave up. And a little arrow on the end. All right, now this is the part where you're going to get a little confused. You got to be careful. You're not counting 0 in this one. So this is currently at the top, so then it's going to go to the middle. So notice that, and then it goes down. Okay, so notice that this guy is one swing here, right? This is going to be concave down. Then we go back to concave up, down, middle, up. Okay. Okay, so this way. All right, so this, the point, there's no point here. It goes from here to here. That's the part that really gets so confusing. Because you jump pi, you jump pi, you jump pi. Did you catch that? I jump pi, I jump pi, I jump pi. I never landed on 0, okay? All right, gang, that's it. That's number 51. I hope that helped. I'll catch you. Bye-bye.